document to say this sits on top of TCPCL and TCPCL has TLS. He said because otherwise, if there's no mention of TLS in the document, they will just reject it because they're being very officious.
Okay.
But to be honest, we'll see what happens. We'll push it. They'll immediately say, "Where's the security?" And we can say, "It's coming. It's a sort of split model thing."
Okay.
I think they're being stupid. I think they're being pedantic about the whole thing.
Well, okay, but I would expect our transport AD to fix this. During ISG discussions about the draft, saying, no,
Yeah, this is one of 3 bits.
And then, I would expect Spencer to do this.
I think there'll be a bit of a fight, but I think we have the answers. I don't think we have. I don't think we have forgotten something vital. So. But it's the politics.
No. Should we start?
Mm-hmm.
Good morning in Singapore. This is the Delay Tolerant Networking Working Group. Where this meeting, as usual, is subject to note well, which is essentially, whatever you say or write is under the provision of this of the IPR of the IETF. There's a proposed agenda. We're going to the first item. Will be hopefully a final update on BPBIS. Then BPSec, AMA, SDN-based DTN, which should be interesting, and some key management architecture at the end. Hopefully that will fill out this meeting. Any agenda bashing, any changes or proposed change? Pretty small number of people here. Ed, do you still want to do? Oh, fantastic. Milestones. So we. Well. Anybody wants to do Jabber scribing? Jabber is kind of getting out of my. Oh, I'll try to do it during the meeting. Milestones. So we done working group last calls on DTN, BPBIS, and TCPCL. As you may remember, we wanted to send both together to the ISG. Those working group last calls were done some time ago. And if you may remember last meeting, the agreement was that given that we have substantive changes to BPBIS, essentially removing custody transfer, we wanted to do another round of working group last call because these were significant changes. And then we did. We ended in September, and working group chairs felt that we didn't get enough reviews of both documents, so we asked on the mailings for more reviews, and we get pretty good and significant ones. So we're working group chairs are happy. Therefore, after the BPBIS presentation, we'll ask the questions to hear, and which is, are we seeing any remaining issues before sending to the ISG? And if not, then we'll proceed to send to the ISG formally. So good that we see our AD in the room, because you should probably expect documents soon in your queue.
Excellent.
Thank you. TCPCL, there's no presentation at this time, but if you have any, we'll ask the same question. If you have any remaining issues that you think should be dealt with before going to ISG, please do so. And BPSec will, after the presentation, ask the question about if it's ready for a working group last call. So that's the plan, and so prepare your answers of those questions. And again, that's kind of our plate of things to do. As you could see, we have more to do, but as we agreed at the beginning, we want to have the BPBIS as the base for everything else before, really moving into the other topics. So I think I'm not sure we're on target for time, but at least the order is the appropriate order. So without further ado, Scott, and I think you have no slides, right?
I have no slides.
For different reasons.
I unfortunately brought a laptop with me as always, and the laptop did not boot when I turned it on in the hotel, and it's currently in the repair shop and may be fixed later today. So I have no slides.
Scott, you need to step a little bit closer to the mic.
Yeah.
It's very sensitive.
Oh, okay. Is that all right?
Oh, yeah, that's
Good
good.
bed. So rather than present slides, I'll just speak extemporaneously for about 30 seconds because I think that's about all there is to say at this point. The review comments that came in on the mailing list since the second work group last call began, I think have been very helpful. There were not an awful lot of them, but in particular there were some from Lucas, I think it's Collard, I'm not sure I've got his last name right, at Technical University of Dresden, who is, my understanding is he's doing a formal definition of the bundle protocol, and in the course of translating the spec into a formal notation, he uncovered a number of places where there were ambiguities in the language, which I thought was extremely constructive. They're small changes, and I think they definitely make the spec a little bit stronger. At this point, as far as I know, there are no major outstanding issues with the specification, and so I am at this point prepared to ask if we can proceed with that first milestone and move the specification into the steering group. So I turn it back to the chairs for this purpose.
Thanks, Scott. I think this is the right moment for anyone to jump to the mic or jump in and meet echo if they think they have substantive comment that they have yet to press the button on. Offline, nobody's approached me to say, I've got a major problem with this. Otherwise, as Mark said, I think we press the button and it ends up in Spencer's queue. Anyone have any comment? That's a resounding silence, which I'm taking as acceptance. So I think we'll press the button on this one.
Excellent. I have one other thing to bring up before I sit down, which is as part of the most recent round of revisions of the specification, we broke the custody transfer functions out into a separate document. The original idea was just to make it an extension, and as we discussed at the where were we? Prague. As I was looking at that, it dawned on me that what we were looking at there was essentially using bundle protocol as a convergence layer, as a reliable convergence layer protocol. And since that happened to align kind of perfectly with using bundle and bundle encapsulation as a convergence layer for security purposes, it seemed to me the simplest thing in the world, and an easy and I think fairly elegant approach to combine the two into a single document. So there's an internet draft out there. It's been about there for like maybe 5 months on bundle and bundle encapsulation with custody transfer, a reliable or an optionally reliable convergence layer protocol. I haven't heard any negative comments on that specification, so while I don't, it's certainly not ready to move into the steering group, I think it's not necessarily inappropriate to suggest that specification be adopted by the working group as a working group document, and the next iteration of that draft be a working group draft. So I would propose this to the chairs as well.
Thanks, Scott. Has anyone in the room read this recently? And equally on Meet Echo? I think the general consensus, as Scott summed up, is this is half of a portion of a document that was already a working group document that was pulled out for expediency. So from my personal perspective, rather than my chair perspective, I support this as a working group document. I think we will have to ask for the formal acceptance on the list, as that's the official manner of doing things. But has anyone got any comment in the room or on Meet Echo? Nope. But I think it's generally accepted, so we'll ask on the list, and I think it will probably go forward. Thanks, Scott.
I think that's the right way forward. Thank you.
So next up, Ed. There's a flicker. I have no idea how. I can't make that monitor work, so you'll have to peer over your shoulder.
I'll just stare into the abyss.
You have to be close to the mic as well. It's a sort of focal mic.
And one question before I start is if someone could take notes. Vicky, if you wouldn't mind. Thank you. Yeah.
That was direct.
I know the name in the room, so. Okay, my name is Ed Bahrain, and I have, believe, the next two presentations. This one is on Bundle Protocol Security, or BPSec. And I wanted to just summarize where we are with the specification, provide a few updates, respond to some outstanding comments from the mailing list, and then talk a little bit about next steps. So, as said, before, for many in the room who have, or online who have read the specification, it has not changed in an appreciable way over the past few iterations. The motivation for the document has stayed the same. There are times in which you need security services applied inside of a bundle. There are times when you do not need security services provided inside of the bundle. When you do not want in-bundle security, then there are other mechanisms for securing bundles and payloads in general. But when you need security inside of the bundle, we needed something new, and that was the motivation for this specification. We did have a couple of design decisions that came forward. Different blocks within a bundle can be secured in different ways. We wanted to make sure that in doing that, the processing order remained unambiguous, and we needed to make sure that we could add and change cipher suite definitions going forward, because different kinds of network deployments on different kinds of devices needed different kinds of cryptographic strength. So to that extent, the overall specification defines two new extension blocks, a block integrity block and a block confidentiality block, which can then be applied to other blocks within a bundle. And it provides the processing order to manage those. And then at the end, there is a treatment on why we think this is an appropriate way of securing within the bundle blocks, and that was added as a request from the working group review, I think maybe 3 revisions back. So in this version, there were no substantive updates. Since the last, we applied some comments that we received on the -05 version of the document. We reduced the occurrence of must. There were probably 7 or 8 times in which must was capitalized and it should not have been. We corrected a very small number of misspellings. And then we updated the security analysis section in 2 ways. The first was we clarified a point relating to the security of long-lived bundles. One of our security reviewers correctly pointed out that there is a difference between the security vulnerabilities of having a bundle live within the network for a very long time versus having a bundle live in the network for a very short amount of time, but allow it to be captured and then worked on because the payload of the bundle is relevant for a very long period of time, which is a small difference and doesn't change the protocol, but it was something we wanted to address in the analysis. And then finally, there was a flawed assumption that we correct the assumption to say that there are certain cases in which certainly signature substitution can happen even in the presence of encrypting signatures, and that if you needed to really make sure that you were guarding against signature substitution, there was a particular level of cryptographic strength that needed to be applied here. All of this, again, is not normative or meaningful in terms of the specification, but was important to the overall security analysis of the protocol at the end of the specification. So there really are only a couple of outstanding comments that remain. I don't, sort of editorially, I don't believe that any of them are fundamental to the protocol itself. One was the observation that the specification defines a key value format for cipher suite parameters and for security results. The actual key value format is not specified in the BPSec document other than how it is captured in CBOR, and it is up to individual cipher suites for BPSec to define the keys that represent those particular cipher suite parameters and the results themselves. One of the reviewers of the document had made the observation that the fact that we would presuppose a key value format for cipher suite parameters and for results could be perceived as levying design on the cipher suites that would come later. And why would we need to do that? And couldn't we just make it an opaque block that the cipher suites themselves handle? I didn't, it was a comment, so I wanted to mention it. My thought was that I disagreed. But having said that, I think that if you maintain a key value pairing, certainly a cipher suite could say, I have a single key, and my single key is my opaque block that I would like to deal with, in which case there's nothing preventing a cipher suite author from using the cipher suites and BPSec in that way.
So Spencer Dawkins says the responsibility. So just to make sure I understand, what we're talking about here is that this would not be a must. Is that what we're saying?
Well, what we are saying is that the comment was that the key value should not be a must and perhaps a recommendation.
Okay.
My response to the comment is no. I would like the key value to be a must, but cipher suites determine what those keys are and what those values are.
Thank you. Thank you for helping me unravel that on a Thursday morning. That sounds like a plan to me. Thank you.
Excellent. Thank you. Another comment that was received on the mailing list was a concern as to whether BPSec could be talked about and standardized in some way if BP Biz was not. The comments associated with that was essentially to disagree for a couple of reasons. One being that while BPSec is a set of extension blocks, the BPSec standard points to the BP Biz standard in terms of how extension blocks such as the BIB and the BCB would be represented and serialized and handled and so forth. And therefore, if there were changes to BP Biz in that area, it would not change the security processing of the blocks. And BPSec does not have redundant information with BP Biz in that way. So they are not coupled in any meaningful way from that point of view. Where they are coupled is BPSec does assume that there is a extension block identifier in the block header of BP Biz, but I think that from a risk standpoint, the chances that that is going to change in any future spin of BP Biz is very, very small. Finally, the behavioral changes to BP Biz that may or may not come about if there are changes to the behavioral changes to BPSec that may come about from any behavioral changes of BP Biz are things that are handled as a matter of security policy and perhaps a matter of cipher suite identification. We really haven't identified any potential behavioral change in BP, if any, that would change the behavior of the BPSec block processing itself. So for those reasons, we did not feel that the comment that BPSec couldn't be started until BP Biz was finished was credible. Another comment was simply that we have older references in BPSec, and I think that's something we could fix at any time. And then finally, there was a comment from, I think, 2 meetings ago, which was in order for BPSec to really be completed, we needed to define a set of interoperability cipher suites, at least one for integrity and one for confidentiality. And we agree with that comment, but the decision we had made at that point was rather than embed those cipher suites into the BPSec document itself, we would create a different document that says these are the interoperability cipher suites for BPSec and send that separately. And so there is a draft for that, Bahrain DTN BPSec Interop CS00, which is a draft, and it talks about HMAC 256, SHA 256 for integrity, and ASGCM 128 for confidentiality, although we can certainly change those, but those are fairly standard and well understood cipher suite specs. And the proposal here is that once we understand that there are no substantive changes to BPSec, then we build the cipher suites, the interoperability cipher suites, which then define the key value pairs in the operation for testing compatibility with BPSec implementations.
Spencer Dawkins. So, not as a expert in this space, but just offhand, I'm guessing that someday before the Earth falls into the sun, we're going to need more. We're going to need additional cipher suites. So this way of organizing the document allows people to change what we're expecting to change easily, without, And if somebody says, "Oh, it's a bigger change than that, we have to open up BPSec," then we would know. That would not happen as a text change because you were, as part of what you were doing to do something with the cipher suites.
Spencer,
So, am I getting that right?
Yeah, the intention of splitting the interop cipher suite into its own draft was so that if a weakness was found in whatever cipher suites were determined as a sensible base level interop suite,
right,
then we could uprev the interop suite document without having to touch BPSec. If there was some fundamental cryptographic failure in the processes in BPSec, then yeah, that would update BPSec. But
you'd have to do that anyway.
Exactly.
So,
it's decoupling something that might change faster than the fundamentals of the process.
And decoupling from the things you're expecting to change from the things that you're not. So this sounds like a plan to me. Thank you.
Excellent. Thank you.
Mark here. However, I think we shall say there's a must reference. There's a direct dependency on this draft, right? You cannot have a complete implementation if you're not implementing both drafts, right? Because we want to have at least one cipher suite which is interoperable, right? So my point is we may want to have those 2 drafts all together at the same time and being working group documents.
So if I recall from, was it 2 working group meetings ago when Ran had attended and gave his we discussed this at that time. And yes, you're absolutely correct that at some point BPSec and the interoperability cipher suites need to come together. I believe Rand's point, although we should check the minutes, was that if they happen to come together in an editor queue, that's okay. And if we allow this one to go forward so that we can focus our efforts on the next, that would be at least fine with him. But that's obviously up to the working group to decide what's the most appropriate thing.
Mark here, I think that I'm not sure it will fly if we send a framework without a default cipher to the ISG. So I think we must send them all together with the ISG to the ISG. I think we must.
Okay.
I'm looking at the
You get the Spencer, or you?
Yeah.
So my point is that if we need a mandatory cipher, right, for that technology, there, and we decided that it's on another document. Therefore, there must be a strong reference between the 2. Must implement this, and also those 2 packaged together at the same time to the ISG. That's my point. Do you agree or not?
Yeah, and so what is the goal for sending it forward without the Cypher Suite document?
Timeliness.
No timeliness. But I mean, so is the answer that everybody's going to peek at the draft and implement that anyway? Because the BPSec referenced that draft, so everybody would just go peek at that anyway.
The returning question, is that a viable option to say to the IESG, look, we're trying to parallelize a lot of this work, so we're trying to get, BPSec is a complicated enough document as it stands. Yes, we have a compatibility suite and we know this needs to be written, but it's lagging a little bit behind. Can you just double check the assumptions with a draft that is a working group document that will be coming to the IESG fairly soon? Or will they just reject that out of hand?
Well, one of they won't. I think if like I say, if I'm trying to help what I'm understanding you guys to be trying to do, I can put in last call text that there is a normative dependency on this, on the Cypher Suites draft, that we're expecting it to be harder to, we're expecting the BPSec draft itself to require the kind of review where you're assuming that there will be a plausible Cypher Suite, but that's not that's really not, which one it is not really relevant to the review of that document, and that you want to start the community review of that document early. Is that fair?
Mark, here, respectfully,
Yeah.
my own personal opinion,
Yeah.
it won't fly at all. If I were a security AD and you're pushing me a security technology without a Cypher Suite, mandatory Cypher Suite, then you're not flying. That's my take, but I may be wrong.
Okay, if you're trying to do something that's not violent to the process, the other possibility would be just ask for early sector review now, which you can do. The chairs can do. Whenever you're ready, and that doesn't require IETF last call.
Clarifying question. Sorry, Rick Taylor here. Early SecAD review of the Cypher Suites or the BPSec?
Of BPSec. If it's going to blow up in sector, that would be you don't have to go to IETF last call to prove it.
So I would just sort of add the comments there that I certainly, from my point of view, both of them seem like viable paths forward. One of the concerns that we had was, to echo Rick's point, that BPSec is fairly complicated enough. An interoperability Cypher Suite is necessary for implementation, because if you don't have an interoperability Cypher Suite, how do you show interoperability? However, if you were to look at these draft documents, I don't remember exactly, but I think the interoperability Cypher Suite is maybe 3 pages. The amount of complexity in that document is relatively small, because you say, well, we're going to use this Cypher Suite, and we're going to point to COSI for the keys and the key enumerations and so on. But more importantly, a question becomes the breadth of review that we are hoping to get from BPSec is to understand symmetric key and asymmetric key, different ConOps, different network deployments, and so on. I would hope that the presence of an interoperability Cypher Suite would not reduce in some way the scope and the diversity of the review that we would hope to get out of BPSec.
Yeah, and just to be clear, I am an area director, but I'm not directing the working group to do anything except the right thing here. I'm telling you what the tools you have at your disposal so that you make an informed decision.
Is that your last slide?
And yeah, that is the last slide. But, well, that's obviously not the last slide, because there's one more beyond it, but it's the last slide with content.
Okay, so one of the things that was on the agenda was pushing BPSec forwards for working group last call. So based on that discussion we've just had, my suggestion as chair would be that we ask for an early SecAD review if the working group is happy to put this into last call. So BPSec would go into last call if people are happy, and we'd ask for a SecAD review and I'll get the words right. So the Security Directorate early review, and at the same time, you are asking for working group adoption, or the working group probably should adopt the interoperability cipher suite as a document, because currently it's Ed's personal draft, and that should be a working group document or a document of that sort. Again, that's a question to the working group. The idea being that we have Security Directorate reviewing BPSec prior to it going to the IESG, and we have an interoperability draft that is cipher suite, sorry, that is a working group document ready to line up at that point. Was that the slightest bit understandable? And does anyone have any comment?
Scott Burley, I think I understood all that, and I agree with it. I think we should do those things that you were saying just now.
Okay, Rick again. I'll break it down into some questions. Does anyone on MeetEcho or in the room have any substantive comment or reason why they believe that BPSec is not ready for working group last call? Obviously, we will be asking this on the mailing list officially, but I'd just like to get a sense of the room. How many people have read it recently is perhaps a good question as well. Oh, good. So I'm seeing that as sort of mild nodding assent. So that's pretty promising. Does anyone have any substantive objection to accepting the interoperability cipher suite individual draft as a working group document? They may disagree with the actual cipher suites detailed, but the question is whether the document detailing a generic interoperable cipher suite selection. Any comment anywhere? Again, we'll take that to the list. And I'm seeing general nodding. So I think yeah. So I think it looks like we've got a way forwards with the Security Directorate review as well. And we can make some progress with this document. Well, with both of them.
Thanks, Ed. Another topic that we had in the agenda that we didn't have a presentation was about TCP/CL. So the question to the room here is, do people feel that it's ready to send to the ISG, or there's still remaining issues about this document? Please speak now.
Victoria Pritchard Davis. I'm just doing a review of this at the moment, so I have got a lot of comments that I will send to the list very soon. I don't think it's ready yet. I'm happy to help out.
And when should we expect your review? I'm sorry, but you put yourself on the spot.
I'm about halfway through, so I'm hoping the next couple of days, hopefully.
Okay. Thanks for the review. Appreciate it. So we'll wait for that review and then see how it affects the spec.
Sorry, this is almost a question to Mark at that point. So I just want to get a feeling of the room. I know we're still seeing reviews coming in for TCP/CL, but I think the general consensus of the working group is that it's an important document that needs to get to working group last call, and it's already in working group last call, and it needs to get to the IESG fairly promptly because the intention of the group is that BPBIS, BPSec, and TCP/CL get released as one package, as a working system of documents. Thank you, Spencer. As a working cluster of documents that define DTN transport. So given that BPSec and BPBIS are now maturing and going up the pipeline, can I ask people to have a good look at TCP/CL to help Brian really drill it down, because there's actually a lot of work involved in doing these things. Brian's done sterling work on it, but I think it's a working group document. It's not just Brian's document, so we've got to help out as well. And thanks for all of you who have been doing good reviews. So next up, Ed again. Is that working, or is that just doing something stupid? No. Almost. LibreOffice slideshow.
That's good.
Is that working? I'm starting to
That
guess.
was.
I have 3 copies of LibreOffice open now for no good reason. Does that help? No.
That's not the best one.
That's BPSec. Goodbye. Get it? No. What is it doing?
It's self-correct.
Yeah.
PDF.
On my screen, it's going.
PDF. Get the PDF.
I'll get the PDF.
So while we're putting that up, I can start with some of the front matter. Excuse me. So several years ago, we started attempting to address the problem of what would it mean to perform network management in a highly delayed or contested environment. And many of the observations that we had made up to that point involved the need for levels of automation and autonomy on individual nodes, individual sensor nodes, or nodes that were acting as cluster heads or other things when they don't have high availability, high rate links back to network operators. And that seemed to be a little bit different than the operational concepts around things like SNMP and NetMod and NetConf. And we started to look at other areas where people had developed autonomy and automation models that went beyond filtering data, but also looked at local state-based evaluation and the engines and the expression mechanisms for putting that together. In around 2013 or 2014, we did some prototyping of a system and some demonstration of how that system could work. Particularly how it could work in highly constrained embedded environments, and particularly in areas where we would have security concerns around mobile code and embedded code. Oh, and here we are. And in all of that, we came up with a couple of things, and we backed into it a bit. We started with something called an asynchronous management protocol. And we realized that we had put, speaking of dependencies and multiple dependencies into a single document, we realized that what we had put together was an operational concept and a system model separate from a data model, separate from a protocol, which represented one potential encoding of that data model. And so what we did was we broke those out into 3 separate documents. The first one we've labeled the asynchronous management architecture, which is the AMA and is in its 06 latest draft, and we will spend a little bit of time talking about that. And then we have put together a data model associated with it, which is captured in right now Yang with JSON examples, and then perhaps at one point an encoding would also be an appropriate and helpful thing in this forum. So today we're hoping to talk about was the asynchronous management architecture updates and the application data modeling. The reason why we wanted to talk about this is that the working group does have a charter to discuss network management requirements, and a question that we have brought to the working group a couple of times in the past has been, if we put together an architecture that talks about system-level roles and responsibilities, ConOps, necessary primitives, and the motivations for the kinds of problems that we are trying to solve and the desirable properties of a solution, does that set of information comprise sort of enough to satisfy the network management thoughts that are in our charter? So, and there's one last graphic to sort of summarize what I was saying in the front matter, which was the thought around this as a body of work was something like the AMA, which we consider aspirational, and then a data model, which would be advisory, and then at some later point, some sort of encoding. So the AMA overview, for those who have not read the document, it has been largely unchanged in the past several revisions. From 05 to 06, the changes that were made were as follows. The changes that were made were as follows, is that we have fixed a few misspellings, and we provided a paragraph that clarified our stance on tabular data or tables as a data structure. In general, the AMA defines service definitions as to what does it mean to manage a node asynchronously. It is not simply monitoring data to get information back to an operator. We accept configuration and parameterized control and administration as part of the responsibility of a network management protocol in this area. And then we came up with a series of desirable properties that we felt tuned this to the kinds of deployments we would be seeing for space systems, for very embedded devices, and for areas where you have resource systems but do not often have periods of connectivity. And those are the intelligent push of information. Pull models, I think we understand, don't work well in this space. Minimizing message size does become important both from a CPU and RAM margin perspective and also from making better utilization of bandwidth when you have it. Being able to identify data absolutely and also create customized views of it. And then, of course, the autonomous operations. In all of that, we propose a system model where you would have agents and managers in the system. We try and reuse as much network management terminology as we can, of course, in describing the concepts. And we look at pre-shared schemas, which are, for where necessary, we support pre-shared schemas because that is, again, part of minimizing the overall amount of information and providing absolute identification of data. We have started discussions with a variety of folks who are looking at writing reference implementations of this, and there are at least 3 that I know of that are in various stages, and there are some communities that are looking at implementations of managers and graphical interfaces, and then there are some communities that are looking at agent implementations themselves in various languages and for various code bases. In general, that is those are the highlights of the architectural model. If you have not read the document, of course, it would be requested that you do so. In terms of the data model, this document takes the primitives and the data structures that are theorized as part of the architectural model and provides a definition of them using Yang. So in particular, we wanted to separate the data specification from any of its potential encodings. We have had discussions. Some people would like a hand-packed binary encoding or a CBOR encoding. Others would like an XML encoding. It became very clear very quickly that the data model, in order to be exchangeable and interoperable across various encodings, need to be abstracted up a layer. And so we have done that in this particular internet draft, which is right now the draft Bahrain DTN-ADM00. And in that, we do have the data model, which is graphically shown on the right, where we have externally defined data, which are data items that are sampled external from the network management system themselves, such as from A to D converters and so on. Literals, operators, controls, which are opcodes or commands that can also be well named, much like the data, strongly typed variables and macros, and time and state-based rules and reports and tables. And those have been put together into a couple of different Yang structures, which are also in the internet draft, which we put together briefly here. And then at the end of it, it rolls up into what we call an application data model template, which is something that we provide to potential users so that they can put their data model together in a generic form. And then here would be an example of a filled out JSON example to that template, assuming that there aren't any future changes to that schema. And then lastly, just a single slide to wrap up, which is that there are a couple of reference implementations associated with this, and they're really mentioned just to show that we are trying to make sure that as we put the data models together and the roles and responsibilities together, that the standards are unambiguous and implementable. And that we're able to have a discussion of representative performance, particularly CPU and RAM margin on representative platforms, because it is important that we spec a system that is unambiguous and that doesn't overly burden the very resource-constrained devices in which we would like it to run. So that is where we are with the asynchronous management work. There are 2 drafts that are out. In particular, the AMA has been out for some time, and a question that has been asked both on the mailing list and in previous working groups is the level of information that is there sufficient and useful to answering our network management questions for the working group?
I think it's worth pointing out that we're also, Ed is meeting with Yang Doctor after this session to go through some of the finer details on some of the Yang encoding, because me personally, without my chair hat on, I think the Yang encoding, I think we're missing a trick here. I think there's some cleverer ways to do this Yang. So we're trying to reach out to the wider IETF community to get some better understanding of what is quite a complicated beast, Yang, actually. It's quite hard. Okay, so Ed, these are both personal, individual drafts. Are you asking for working group adoption of these, or are you just asking for people who may be sat in this room who might be interested in working with you on this? I'm unclear.
Oh, so my apologies. So I am asking for working group adoption of the AMA spec. We have had it as a topic of conversation for several working groups. I know that it's gotten a fair bit of review over the past year and a half. And has not gone through any substantive changes in the past year and a half. And then if anyone would like to participate on the ADM, I would like eventually for the ADM document to also be adopted, but I think that would be something that should come after the AMA document.
I think it's worth pointing out at this point that the asynchronous management methodologies that Ed is proposing here is I don't think the intention would be that this would be the one true way of managing DTN-based devices. I think your suggestion, and correct me if I'm wrong, is that this is a way of managing devices that fits a certain use case. For other devices and systems using DTN, you may want to use a more connected management solution or whatever. So this is one solution to the problem, and I don't think the feeling from the working group is this shouldn't be the only way that we consider DTN-based networks to be managed.
Scott Burley, and it's not only, my understanding is it's not only the only single one true way to manage delay tolerant networking, it's also a potential way to manage networks other than delay tolerant networks. Is that correct? And I think that's an important point for people to be aware of, that there's the utility here beyond the DTN working group, potential utility beyond the DTN working group.
I think I'd agree. I think this has utility outside of this working group, but I want to stress that I don't see this as the exclusive management proposition for the DTN working group. I see it as a useful one, but not exclusive.
So I'll just comment that so certainly the thought behind the asynchronous management architecture was to say if you make certain assumptions on the characteristics of your network and your ability to manage them under those scenarios, then this is the architecture that you will find yourself falling into, even if you wind up doing that with a different data model or with a different set of encodings. In that sense, it's hard to say something is the one and true, at this early stage. But what we can say is we have not at this point identified operational constructs that cannot be fit within the AMA architecture. If there are pre-existing deployments, or if there is additional back channel or alternative mechanisms that essentially do not incur the constraints that AMA is trying to solve, then certainly there are other options beyond AMA. But to Scott's point, when we have talked to some people who are not deploying DTN, they've come back and looked at this from an automation standpoint and said, really as a matter of cost and understanding, putting that level of automation into these devices that does not involve mobile code, that does not involve running, and deploying scripts, and that does not require, the level of attention that other solutions that they're trying to deploy requires, has been motivating for them, even though they do have the connectivity. So it's difficult to make a one-to-one mapping between where this is. So anyway, but the long comment is, I'm sure there are other ways to get up the mountain, if you will, but the AMA, I believe, is uniquely suited for DTN. in those constraints, even for the non-DTN people who are coming in. They're coming in because they appreciate the autonomy and automation that we know we need as an existential enabler, as opposed to simply a cost saver.
Yeah, understood. Thanks. Okay.
Right.
So nicely following from that, I think the next presentation is on an alternate way that one might want to manage things over DTNs, which is why I was setting up to say that although personally I think this is a very elegant solution to automation, I believe there are other ways to manage systems that are using DTN as a transport. So thanks, Ed.
Yeah.
Remotely. Yeah, look at that. So it is. So next up we have Taijin Li. I'm afraid my Chinese pronunciation is really bad, so I can only apologize if I have your name wrong. I've got to try and make this work. Hold on. Slideshow. Start. Yeah.
Thank you.
I know, genius, isn't it? You have to be very close to the microphone.
Okay. Morning, everyone. My name is Taijin Li, and I am now a doctoral student from Beijing Jiaotong University. Today, I will give a presentation about the draft about the software-defined DTN-based satellite networks. And I'm very sorry for my poor spoken English and English listening. I'm very sorry. This is the main part of the draft. And this draft is a use case of DTN, and we apply DTN in the space networks. And the research in the draft is implementation of DTN, and it is supported by a national project in China. And in the project, we aim to build integrated space and terrestrial network. And my focus is on the space network, and I propose to use DTN for data transmission and SDN for the control. First, I will introduce why I choose to use DTN in the space network. As we know, the space network have several characters. For example, the transmission delay is very long, and the satellite links interrupt frequently. This is the comparison of the protocols that can be used in the space network. As we can see, DTN is designed for the space network, but it is still in the experimental stage. However, these years, many experiments has been conducted about using the DTN in the space network. Scott may know this, and many experiments are conducted by NASA. And we can see the result is very good.
It may be interactive slides aren't working. Oh, no,
Okay.
there we go.
All in all, DTN is typically applied in the satellite in the scenes where there is no guaranteed end-to-end path between the source and destination. The original design is very suitable for satellite network links. Okay. Then I will introduce why I chose to use the SDN in the space network. As we know, there are many problems in the traditional satellite networks. For example, slow configuration, inflexible traffic engineering, and inefficient service delivery. So we need a new design. In the past years, a lot of projects are focus on the new architecture of satellite satellite networks. For example, the India Nest, ISCOM, SCAN, OneWeb, and O3B. And in China, we also have many national projects about the new satellite architecture. And so in our project, I propose to use the SDN in the space network for better control and better management. Then I will introduce the 3 key points of the design. The first one is the separated control plane and forwarding plane, and which we place the controller on the GEO satellite and the forwarding devices on the MU and the LEO satellites. And to separate the control plane and the forwarding plane, we use two different sets of ION script, and that is we use the ION script of the control plane, control link, and we use the ION script of data link. The 2 sets of ION script are different. So we in this way we separate the control plane and the forwarding plane, and the whole architecture is called the software-defined satellite networks. It is also called the SDSN. And the second one is the bundle tunnel. We deployed OpenFlow over DTN by the method of tunnel. That is, signaling packets are transmitted in bundle tunnel when controller communicates with the switches. And as we can see from the figure, the OpenFlow signaling data are encapsulated in the payload of the bundle packet. And the third one is the satellite gateway, and the satellite gateway is located between the space network and the terrestrial network, and we deploy the DTN to TCP/IP by directional protocol translation function on the satellite gateway. And in addition, we modify ION so that it can support the IPv6. Next, I will introduce the model of SDSN. When designing this model, we have to consider the characters of both DTN and SDN.
Yes. Sorry, my Linux laptop doesn't particularly like PowerPoint.
Okay,
I can only apologize.
In SDSN, the transmission of the packet can be divided into 2 stages. And the first stage is that the packet arrives at the satellite and the packet is stored locally. And the second stage is that if there is a available path, the packet is forwarded to the next hop, and the controller will tell the packet where to forward. And both of the 2 stages can be modeled as MM1 queues. And to model the OpenFlow network with current theory, we make some modification, and we modify the model in the last slide to the model in this slide, and we make some equivalent transformation. And so we can use the Jackson model in the current theory to model the satellite nodes. And then we conduct the experiment to verify the model. And we deploy the post controller ION and the open switch to conduct the experiment. And we ran the model in MATLAB, and we compare the experimental result and the numerical result. And as we can, and the contrast term is the file sorting time. What is the file sorting time? It is the first packet of a file arrive at a satellite to the last packet of a file leave the satellite, and this time is called the file sorting time. We compare the file sorting time of the experimental result and the numerical result. And we can see from the figure that the numerical results and the experimental results are very close. Then I will introduce the implementation of SDSN. These are the parameters of the three-layer constellation. We use this constellation. It can't. It is moving. It is moving. Yeah. The constellation contains 66 LEO satellites and 10 MEO satellites and 3 GEO satellites. And this is the integrated space terrestrial network protocol. And my focus is in the satellite network. And we have several high performance servers, and we deploy the satellites on the OpenStack, and OpenStack are run in the high performance servers, and we deploy the DTN to TCP/IP protocol translation function on the SG1 and SG2. SG is for the satellite gateway, and the SNMC is the satellite network management center, and all of the virtual nodes. The nodes in the terrestrial are real computers, and the nodes in the space are virtual nodes. So both of the virtual nodes and the physical nodes consist of the whole protocol. And the links are configured by Linux traffic control tool, and the connections and the parameters of links are abstracted from STK. That is, we run the three-layered constellation in STK and get the parameters of links, and we use the Linux traffic control tool to simulate the links, to simulate the parameters of the link. And this is the machines of our protocol, and we have 8 high performance servers and 28 computers. We use, as I have said, we use the high performance servers to hold the virtual satellite nodes, and we use the 28 computer to create the terrestrial network. And the terrestrial network contains a small data center and a mobile network. And then at the last, I will introduce 2 use cases. I have also make it that it can't move. The first use case is the the first use case is site diversity. It means that a user want to send some data to the terrestrial network, and first the link is the transmission link is the link 1, but the weather becomes very bad and the packet loss rate increase. So the controller can collect this information and send the information to the SNMC. SNMC then make a new forwarding rule and send it to the controller in the GEO satellite. The GEO satellite then allocates the forwarding rule to the MEO satellites, and then the path switch is switched to the link 2, and this figure is the result. The second case is the resilience of the network resilience, and this is case tell a story about one host want to in the domain 1 want to send some data to domain 2, and but suddenly switch in the path breaks down, and the controller in the terrestrial network collects this information and make new forwarding route, and the path switch to another path in the terrestrial network. But suddenly, unfortunately, another switch in their path burst down again, and then this situation is collected by the SNMC, and SNMC make a new forwarding routes to steer the traffic for where the space network. Then we can see the red line is the path that the data transmitted where the space network. And I think this use case can be used in the 5G backhaul network, backhaul service. And this is the result we get. This figure. Okay. These papers are the related work that we have published, and all of the papers are about the SDSN and the integrated space and the terrestrial network. And if you are interested in our work, you can download these papers and read it. Thank you very much.
Questions?
Ashish Mishra, SES Networks / O3B Networks.
The microphone is very sensitive, so you have to sort of speak straight into it.
Can you hear me now?
Yeah.
Perfect. How do you suggest the GEO and the LEO / MEO assets talk to each other? There is no ISL between GEO and other orbit satellites.
Sorry. You mean why we are using the GEO satellites for control?
No, I mean to say I'm not aware of any GEO satellite and a MEO satellite that have an inter-satellite link that works.
Sorry.
Do you understand the question?
No.
So
back
if
to
you go
the-
to the
the
layered
links.
architecture,
The links between the satellites? Between the satellites, between GEO and LEO. How do you communicate between the two? Because it's how does the control one and the forwarding one talk to each other? Is that the right question?
yeah, in the real world, I'm not aware of any satellites that can do that.
You are talking about in the real world, or in our protocol?
No, in real world, there are no announced satellites or existing satellites that have that inter-satellite connection.
But the satellite networking is, I think, is, and for example, the SpaceX and the O3B and the OneWeb, they propose to use many small satellites to create a network, and so there must be the satellite links between the satellites, and so
No. So OneWeb is not going to have inter-satellite links. O3B Networks does not have inter-satellite links. It's operational. SpaceX has announced that it's going to have inter-satellite links, but only within the LEO assets. SpaceX is not planning on launching any GEO asset.
yeah. In China,
There's two types of companies that have a GEO asset with a lower orbiting asset. There's governments, so NASA will have it, US government will have it, China government will have it. Yeah, and SES, which has the O3B assets now.
in China, we have some research about the satellite links you're talking about, and they use the laser link, and for now it is, you're right, it is very difficult for two satellites. They are because they are very, the distance between the two satellites is very long, and the laser can very hard to communicate. It's very hard, yeah. But the work in this draft is about something maybe happen in the future, and our project is the work in the draft is based on our project, and our project is someone that we research the future technology. Yeah, so we do some research about this.
So I have a
Sorry, can I just interrupt? This might not be the right forum to talk about LEO to GEO satellite link technology. It's, so we're about the DTN transport,
Right.
and if I think I understand, Taijin Li was saying that this is a prototype implementation to test the use of DTN for the management rather
Right.
than individual satellite technologies. So I think that's probably out of scope. Sorry.
Fair enough. Then in that case, I have a slightly more relevant follow-up, and let me know if it is relevant for this forum. The choice of using a geo asset for the control plane is interesting because even MEO satellites are closer to the Earth than they are to a geo asset. So you would have a faster connection to a ground station than to the geo satellite.
So you're talking about why I propose to use the geo for control.
Right.
Can I interrupt again? I'm not sure of the relevance of that. I don't think the IETF's the right forum for that. I think it might be more CCSDS. Sure, talk about it offline afterwards, but
We'll take it offline.
yeah, I'm
Okay.
absolutely. I think it's an interesting conversation for you guys to have later.
Yeah. Thanks.
Okay. Thank you. Thank you.
Hi, Ed Bahrain, APL.
Hi.
So there has been a lot of good work that is trying to understand how do we take these kinds of concepts, LTE concepts, open flow concepts, SDN concepts, and move them into these areas where we have the delay and the disruption. A question that I had, and I have not read the draft, and I apologize for that, is do you feel, where do you have to modify the protocols so that they can account for the delays? Because without talking about spacecraft architectures, when we come back and say, the links in general, whether it's a GEO link or a LEO link or some other link, the links are not reliable. They are much slower. It is one of the reasons why in these particular instances, many organizations don't want to spend the money to try and make them reliable. So when we talk about this, are you changing any aspect of the open flow or the SDN protocols themselves, or are you only tunneling them over BP?
Yeah, you're right.
Inside of BP.
Yeah, you're right. And the link between the GEO and the MEO is not reliable. Yeah, you're right. And this may be our next steps to work on this field. And we for now, and we just deploy the open flow on the open flow. We just deploy open flow over the DTN, and not so much modification. We have not done much modification, and we just write a small model to build the bundle tunnel when the GEO and the controller and the switches want to communicate with each other. So yeah, and not so, we have not done much modification, and yeah.
No, excellent answer. And you may find that may help in some of the situations as well, as to look at making the applications that sit above BP delay tolerant as well.
Yeah, thank you.
Jörg, I'm a bit surprised that SDN, that open flow messages are actually happy being delay tolerant. From what I understood from the SDN community is that they were somewhat surprised to realize that different latencies for reaching different switches in very well connected and short RTT networks tend to raise or create problems for inconsistent switch states that might result in all kinds of things, because you're installing in different rules and different switches that are ideally supposed to take effect immediately. So making this even more delay tolerant does seem to raise a number of issues in terms of switch configuration consistency. And I'm wondering whether you have any thoughts on this.
The open flow just work between the GEO and the MEO. So the signaling data or the control data are not stored in the nodes. Just the packets, the data packets are stored on the nodes, and the open flow signaling data just controls the forwarding. So they are not stored in the. Yeah, you're right. The signaling data are not stored on the node. They just control. If we the RTT between the GEO and the MEO is very long, but in our experiment, it works okay. It is okay to encapsulate the open flow signaling data in the payload of the packet of the bundle packet, and it works. It does work. Yeah.
But if they are not being stored and forwarded, then why do you need to encapsulate them in the first place? It seems to be a hop by hop link then.
Because we use DTN in the whole settlement network, and we don't want protocol transmission in the network in the space network, because the satellite nodes are limited in processing capabilities. So the whole satellite network are based on DTN, and so we want a better control in the satellite network. So we use the SDN in the satellite network, and so we have to think about a method to deploy the open flow on the DTN. So we choose to encapsulate the open flow data in the bundle packet.
Right, but then it sounds like you should be having some idea about a two-phase commit atomic transaction protocol in order to make sure that all your elements in your network are configured to the same version of the state that you want to achieve at the same time. And I haven't just that seems to be an upcoming problem to me. But
thank you.
Maglasha, can you move the slide for the gateway? I'm not sure I understand this one. From the graphics, you seem to translate TCP into bundle. Are you tunneling, or you're translating congestion control of TCP and window size and all that stuff? How does that work?
Because the whole protocol is about a space and terrestrial integrated network. So we use the TCP/IP in the terrestrial network, and we use DTN in the space network. So when the data translate between the space and the terrestrial, there must be a protocol translation. And we just when we do this, we just get the payload of the TCP packet and encapsulate into and rebuild a bundle packet and send it to another end. And there is address mapping as the satellite gateway. For example, the IPN 1.3 is mapped to another IPv6 or IPv4 address, and then when the translation occurs, the contents or the payload are encapsulated in another packet, and the address are also translated from IPv4 or IPv6 address to the IPN address.
Okay, so you're essentially taking the payload inside the TCP and then put it in bundle.
Yeah.
And then you terminating the TCP connection there.
Yeah. Terminate. Yeah.
Adrian Farrell, thank you for bringing this here. It's an interesting discussion, and thanks to the chairs for making time for it.
Thank you.
On the topic of, on the topic of SDN and reliability, I think that the SDN architecture and application is delay tolerant. So the question about whether we need a two-phase commit or whatever is really a choice of what SDN protocol is used. If you use an SDN protocol that is resilient because it's got an acknowledgement, then the network will not get out of phase, and DTN is all you need. If you use an SDN protocol that makes assumptions, like it's a write-only, non-acknowledged protocol, then yes, you will get synchronization issues. So there's a little bit of investigation to be done on whether OpenFlow is the right SDN protocol to use.
Okay, thank you.
Scott Burley, JPL. Two things. One is the diagram that is on the screen right now, the satellite gateway. This will gatewaying between TCP/IP and bundle protocol at the satellite gateway clearly will work. I would propose that it would be even easier to run bundle protocol underneath the application data from the ground node all the way to the satellite node, rather than gatewaying, and just have the satellite gateway instead be a DTN bundle forwarder rather than an address matcher. But that's we don't have to talk about that right now. I just think that's a cleaner, easier, and simpler and easier to manage configuration that we could discuss. The other thing I wanted to observe is that I unfortunately don't know a darn thing about SDN, but if there is an issue about coordinating SDN configuration values across the network so that everything is consistent, then the delay tolerant way of doing that would be to encapsulate the SDN messages in, I think, in time tagged messages, and so that they would be distributed in advance of the time that they need to become effective, and then and received in advance and held pending the effective time of messages, so that everything does come into alignment and consistent configuration at the same time based on time. And maybe that's beyond the scope of what can normally be done with SDN, but it seems to me to be a straightforward way of ensuring a consistent configuration across the network.
I wonder, how could geos ensure the control of the MLOs and LEOs? Could you give us a general RTT time, and is it possible that the whole system would be broken when geos go wrong, or be attacked by huge amounts of fake forwarding switches, since the number of geos are strictly limited? So how could you approach the security issues of SDN in your system?
Yeah, you're right. The security about this system is a very important research point. In our architecture, we have for now we have 3 geo satellites, and all of them are responsible for the control. And for example, one geo is attached or it breaks down, and the other satellite will take up the responsibility and control the network. If all of the three geo satellites breaks down yeah, you're right. The system is broken. Yeah, but for now, the satellite communication system is just for one GEO satellite, and the data sent from the terrestrial the ground and to the GEO satellite, and the GEO satellite forward the data to the ground. And if this satellite is detected and all of the communication system breaks down. So I think for now we just have to make more satellite link. We just set up more satellite. For example, we have 3 now. For example, in the future we may have 5, 6, 7, or 8. In my opinion, this attack cannot be pretended. If your enemy want to attack your system, they just contact the controller, and we can't pretend it. In the terrestrial SD network, if we break the controller, and the whole system breaks down. So it is similar to the SD network in the terrestrial network. And if we break down the controller on the GEO satellite, yeah, you're right, the whole network breaks down. Yeah. So this is an important research point, and we may do some research on if one GEO satellite breaks down, and another GEO satellite will immediately take the responsibility to control the whole network, and we may do some research about this.
Thank you. And maybe we could figure out that whether we could carry out a plan B, maybe that the whole system just downgrade to the formal DTN1.
Okay. Thank you. Scott Burrow, JPL. And actually, on this last topic, a central concern of DTN architecture for about the last 20 years has been this kind of thing, and the sort of canonical way to address this, if I understood the problem, if I understand the problem correctly, is to do BPSec essentially signatures on messages, and for all the forwarding nodes that can pass data to the controller to require that the payloads of all of the messages pass integrity signature verification before they'll get forwarded, so that the controller is shielded from inauthentic traffic. We should be able to do that kind of thing with the protocols that are being designed and that have been prototyped in the earlier versions of the DTN protocol, DTN stack.
Okay. Thank you.
Thank you very much. If we don't have any further questions, is somebody monitoring Jabber? I know we asked for a Jabber scribe. Okay. If you are on MeetEcho or Jabber and you wish to speak, can you use the interactive walk to the mic things, as we are failing to monitor Jabber at the moment? Thank you very much for that, Lee. Next up, I think we have Kapali presenting for... Let me just find his slides. Download them. Oh, there we go. Colin. I didn't recognize them. Yep. The left. Let me just work out how to. Why is this? So we will, I hate this screen. There you go.
Right.
Yeah. You have to be close to the mic.
It's good.
Yeah.
All right. Good morning, everybody. So I'll be speaking about this internet draft that we have put up, and that's the URL for that, the footer. And this is about delay tolerant key administration. How do we do key administration for the DTN network? So the motivation for this particular draft is on-demand interactive communications cannot be assumed in the DTN model. So that's one reality. The other one is today for key management, we use for example, in SSL, we have certificates, and for revocation, we have online certificate status protocol. And these require interactions, near real-time interactions. And so that's clearly not possible in the DTN communication model. So we need a DTN-friendly public key distribution and revocation protocol suite. And this talk is about that. So the way I've organized this presentation is I've just done a screenshot. So whatever you see on the black font is straight from the RFC, Internet Draft. And the blue fonts is annotations for this presentation. So this is the high-level architecture for what we are proposing as delay-tolerant key administration. And it's actually abstract. So there are three entities: key owner, key authority, and key user. The key owner is the person or the entity that possesses the private key corresponding to the public key that needs to be distributed. The key authority is responsible for ascertaining the association between an address and the public key. So we have node ID and key. So that association, the key authority has to authenticate, and if it is satisfied with authentication, it has to periodically send a list of authenticated, such authenticated tuples to a distributed key user. So this is the high-level abstract architecture, and these are the three entities. So when we go a little bit towards the detailing part of the architecture, so we assume this kind of DTKA system interconnection, and so we assume that between the DTKA key agents, so I did have to tell you something about the DTKA key agent. So we see the key authority here, right? So the key authority in the abstract flow is shown as a single block. Now, that is a requirement for delay-tolerant key administration, that there should be no single point of failures. And we have to really distribute the key authority to multiple entities in a fail-safe manner. And how we do that is this. If you're an object-oriented programmer, you can think of a key authority as an abstract class, and we will have key agents, which you will see in the next slide, as concrete classes that really implement it. So that's the flow over from this slide into this slide. So we have DTKA key agents, and a bunch of these DTKA key agents act as the key authority for a given application domain. And we assume that all the DTKA key agents are connected by a reliable link so that they can synchronize. So the authorities for that particular entity are synchronized within each other. And the communication between the authorities and the key users, that can be delay tolerant. And the communication between the key owner and the authorities, that can also be delay tolerant. In fact, we do not expect any real-time communications. And one of the important system configuration spec here is the public key of all the key authorities are physically configured on every node. That's the system bootstrapping, something like how your browsers have the root public keys in them when they are installed. So this is something like that. So coming back to the abstract concept, this is the avoiding the single point of trust that I said previously. And so the key authority role is distributed amongst multiple key agents. And we'll talk about more of how this is done, how it is distributed, and how it is made fail-safe. We are going to talk about that. So we will now concentrate on the first link, that's the interaction between the key owner and the key authority. We call that the node key registration. And this is a protocol where the key owner claims a particular association with the key authority, and the key authority has to authenticate it and see if that association is acceptable or not. And in the draft, we identified two such modes of communication for this first link. One is an out-of-band bootstrapping. This could be a USB link. So the key owner will have to create a USB, give it to an authority. The authority will physically go and verify, and if it is valid, accept it. That's the out-of-band approach. And that's an in-band approach also possible if the node ID was issued a public key previously, or previously the key authority accepted a node ID previously and it wants to get a new public key. So in that case, the in-band is okay. So both are allowed in the draft. So now that we saw how the key owner is going to claim a particular address key association with the key authority, the next phase is, okay, now the key authority has accepted the tuple as authentic, and how does it send it out? So it has to send a list of authenticated node. It's basically bulking. It's a bulk send. So it has to collect all the authentications from key owners and send it as a bulk. It can send one if it wants to, but the association is in a bulk. And this particular communication, we assume is going to be protected by the bundle integrity block of DTN, employing the key authority's private key. So this is why everybody has to have the key authority's public key, or every key agent's public key must be available with everybody in the system. And again, instantaneous receipt of these public key updates is not assumed. So they are just bulletins. They are going to go with delays, and different key users are going to receive the bulletin with delays, with variable delays, and they will have to process it locally, asynchronously. So the message format for the key updates, this is what we have proposed for the bulletin. So that's the list of key authenticated node ID, key tuples. And the bulletin format is basically, there's going to be a bulletin hash. So this will be formed by every key agent that belongs to the aggregate of key authority. And each element of the bulletin will have a key information message, which is basically a node ID, effective time after which the key is valid. So it is some time in the future, and this node ID, public key is valid after that time. And again, there is an instruction about assert, revoke, or rollover. So these are the three operations on that particular key information message that asynchronous entity can do. Yeah.
Rick Taylor, very quick question. Why the bulletin hash? If you're using BPSec, then you've already got integrity and effectively hashmark already at the bundle layer. Do you see benefit to, is this for interoperability where you leave the DTN somehow?
No, it is like we will see that we have to eventually, we are not going to send this bulletin as is.
Right.
So we are going to code this bulletin and send. So this bulletin is going to send us code blocks. So, and multiple key agents are just going to send the code blocks and not the bulletin. So they have to associate the various code blocks, and the key hash is going to help them as a unique pointer from multiple people.
Scott Burley, JPL. Just to interject here, one thing that may not have been clear is that the before the list of authenticated node IDs and public keys is issued, that bulletin has to be developed as a consensus among all of the agents of the distributed key authority, and that single bulletin has to be bit for bit identical as distributed by each of the agents individually, and the bulletin hash is what essentially identifies that bulletin and validates that it is the bulletin on which all of the agents reach consensus.
Right. So we'll see. Yeah, so it's basically a unique pointer that all the key agents agree, and they must agree, and we assume that they have agreed previously. Yeah. Thank you. So this is how the bulletin is formed, and again, as I said, the bulletin is not sent as is. The bulletin is erasure coded. That's a Q plus K erasure coding done on the bulletin independently by each key agent, and they form this code blocks using the bulletin. Again, as Scott said, every key agent must use the same bulletin in the same bit order, and that's why the hash ensures that the bit order is correct between all of them. And so a Q plus K erasure coding is done at authority X, and it's a little bit more than erasure coding. We'll come to that in the next slide. But Q plus K erasure coding is performed, and what is sent on the wire is actually the code blocks. That's figure 4, and that's a bulletin hash, which is carried over from the bulletin, a code block number, which is assigned for that particular key authority, what a set of code block numbers that that authority is allowed to transmit, and the code blocks themselves. Now, as I said previously, these code blocks, the security for this is over the bundle integrity block. So when we send it, that is a natural signature that's present in the bundle integrity block, and everybody gets a signed copy of this code block. So we are not dealing with that. BPSec will take care of that. And just to, this is a fictitious example that we have proposed of how we can assign a particular code block number for a particular key agent, right? So over here, it's a 7+1 erasure coding that we assume is used, and we assume that 5 out of 8 key authorities, the code blocks from 5 out of 8 key authorities have to be received before the bulletin is reconstructed. Minimally 5 out of 8. If you get more than 5, that's good. And that's where I think the consensus that were reached previously, now every receiver, key user, can verify that the consensus was indeed reached. So this is sort of a proof that the consensus is reached. And so, for example, over here, we have 8 key authorities, KA1 to KA8. And because we have a 7+1 coding, we have blocks 0 to 7 for a particular block. And what we do is we assign, we inform, like again, this is a system level configuration that every user is told that these are the, like KA1 will only transmit code block numbers 0, 1, and 2. And if any other code block is received by from KA1, that is ignored. So this is a system configuration, system security configuration that is configured manually, just like the root public key configuration is configured manually on every node. So we have KA1 to KA8, 3 blocks each, and you can see that to get at least 7 blocks, they have to wait for messages from at least 5 key authorities. For example, K1, 2, 3, 4, 5, when you get everything, of course, there's a redundancy built in, you get 6 blocks, and you can reconstruct. So this is one way of doing it. And again, coming to the summary of the presentation, DTK is a public key distribution and revocation mechanism for DTN, and it uses bundle protocol securities bundle integrity block to provide non-repudiation and authentication, and it uses Q plus key erasure coding to distribute trust in key authorities, and it is configurable. The number of key authorities is configurable, and the idea of a key authority, many key authorities aggregating into a key, many key agents aggregating into a key authority is to realize no single point of failure requirement for DTK. And the details are in the internet draft. Thank you.
Rick Taylor again. I really like this. Sorry, it took me a moment to get up to speed with the hash. The one question is, you don't have any temporal consistency checks in here, so that you get your code blocks for now with drop and add, but it's not sort of cross. It'd be nice to include the hash of the previous update you were supposed to have got. A bit like looking at a Git tree. I can start to see some generational information.
Right.
Have you considered that, or is that going to break something I haven't thought about?
No, I think the reason it's not like, this is a minimal information set. So here so that's one assumption in DTN that is inherent, is the clocks in every DTN node is synchronized. So that's one assumption. And we actually carry that assumption forward by saying, okay, now that the clocks in every DTN node is synchronous with a little bit of drift, maybe a few seconds drift is tolerable. And then the key effective time is a synchronization at future point in time. So
yeah, I understand the fact that you can pin when this bulletin hash should come into effect. My question is, if a node has been a key user node has been out for a long time away from the system, comes back, receives a whole batch of bulletin hashes.
Right.
All right. And doesn't know that one misses sufficient bits of the code point to not realize a revocation has occurred.
Right.
It would be nice if, in the same way that you've got your FEC allows you to say, oh, I haven't had a sufficient bits to see consensus, to do the same through time, to say, oh, I've missed update number 17. I shouldn't be using 18 and 19 and 20 keys yet because I don't know what's happened.
Right. I think that's a good question.
Almost having prev hash after your bulletin hash in your packet might solve that.
Right. I think if the question, as I understand, is what if one of the key users completely lose on one bulletin, and how would they synchronize after that? And today, I think we have assumed that a bulletin that is sent is going to be received. But I think that's a good point that we can consider. Thank you.
Scott Borley, JPL. That's what I thought the question was going to be, I had an answer for, which is that the synchronization of time across the nodes is not necessarily critical, because the application of the keys by effective time is on the basis of the bundle creation time and so it doesn't, even if your clocks are wildly off, you apply the public key that matches the creation time of the bundle to which the public key is being applied.
Mhm.
But I understand that's not the question. The question is
It's
what do you do
Lamport
if there's,
event order.
yeah, so do we need like a blockchain kind of thing?
Or I was going to avoid blockchain. I was
Yeah.
going to say more Git history style rather than try
Yeah.
and get into blockchain.
Well, but I think that's a really good point. I mean, what if a bulletin gets missed altogether? What do you do about that? And I think that's a really good thing to consider. The one other thing I wanted to mention is it might not have been clear from the way the overlap diagram was built. The intent of that overlap is to ensure that not only is there no single point of failure, there's also no single point of authority. That is, no single bundle agent is allowed to say, here's what the bulletin is. There has to be a consensus, and that's why only a subset of the bulletin can be issued by each node. And not only can there be no single point of failure and no single point of authority, but also no single point of veto. And that is, no single node that decides to issue junk information can sabotage the system.
Right.
Ed Brain, APL. When we talked about the thresholds for the actions, accept a key, revoke a key, roll over a key, is there a concept in the spec of being able to have different thresholds per action? So the question would be, would you consider a time in which the number of key authorities necessary to add a key is different than the number of key authorities necessary to revoke a key?
Okay. Can you repeat the question, please?
So the vulnerabilities are a little bit different. If I come back and say I have a higher burden of proof to accept a key because I don't want to use a key that is wrong, is there a lesser burden of proof to revoke a key? Because if a key is revoked, but it's going to take me a certain amount of time before I see enough key authority messages, do you have a concept that those different actions require different levels of consensus, or do they all require the same level of consensus?
Yeah, the current design is they all require the same level of consensus among, like, if it is a 5 out of 8 scheme, at least 5 people should say revoke, or at least 5 people should say accept.
Okay.
Or roll over. So that's coming across all 3.
So then the comment would be that may be fine, but it may be dependent upon the network and the kind of traffic as to whether or not you feel that the vulnerability stance is the same if you keep if you keep it to 5 in all cases.
Yes, so that's a configuration, by the way. So the T out of N is a configuration for the operation. So they could actually do 1 out of 1, in which case it's a veto. If they say 1 out of 2, 1 out of 3, so we provide the mechanism to have a liberal policy, but the policy is actually a configuration detail of the operation.
Oh, it is. So it does have the granularity of the operation. So you could say assert is this, revoke is a different.
Yeah, but the only the mechanism does not provide, as you rightly identified, is assert, revoke, and rollover have the same consensus model. Like if it is 1 out of 2, 5 out of 8, it's the same.
So then the comment will be, it may be worth just investigating whether to add that extra level of fidelity.
Okay, so revocation is done faster than something like that.
Well, there may be cases, there may be network deployments where I need 5 or 6 key authorities to agree on a key before I add it. But if any 3 revoke, then I'm going to revoke. And that may be a function of the dynamics of my network and how rapidly I need to revoke a key versus how long I'm willing to wait before I accept a key.
Got it.
Sorry, Rick Taylor, just jumping the queue slightly personally. I can see that being quite difficult with this because you wouldn't know whether whether you were allowed to accept the bulletin with your Q out of T until you'd accepted the bulletin. So I think it's meta information. I agree with you that this is config. How you would dynamically alter the config may be another whole protocol. Yeah,
Scott Burley, JPL, just because this is a topic that's very interesting to me. A concept here has been that the key revocation can be just as mischievous as false key distribution. So it may be that a different level of scrutiny applies, but that in itself seems dangerous to me. But if we needed it, then I think it would have to be a separate, the way this is designed, it would have to be a separate channel. You have to have like a channel for key distribution and a separate channel with a different set of configuration parameters for revocations.
it could conceivably use, sorry, Rick Taylor again, it could conceivably use the same mechanisms, but you're right, it's a separate out-of-band channel from this.
Exactly. This is all based on multicast, and it could be different set of multicast groups. One other thing I should mention is it's not actually the bundle integrity block anymore, and that's now the block integrity block.
Sorry. Thank you.
Any further questions? Otherwise, thank you very much, Kapali.
Thank you so much.
Thank you. Oh, quick question. Are you asking for working group? This is a individual draft. Are you asking for working group adoption, or are you interested in feedback and might do another up rev and decide later?
Yeah, I think we just discussed this. I think we are just we are not asking for a working group now. We are asking for feedbacks. I think we will be looking at it at some point in the future.
Okay, brilliant. Thank you.
Thank you.
So we now have a bit of an open mic. So if anyone has any general questions, queries, comment, announcements, entertaining stories, otherwise, Brian Cepos is heading to the mic. I think you have to press the red button, don't you? Go ahead, Brian.
Hello. So I know I don't have a slot, and I know I didn't ask for one, but since there's a little bit of time, I will just mention that the comments that have come in yet on the TCPCL have been good editorial ones, and so far there's really been only one pending change to the protocol itself related to the size of the extension headers, and everything else beyond that, encoding the size of the extension headers that was commented on. But besides that, all of the comments have either been typo, nomenclature, or affecting the sort of alternate processing paths rather than the main typical processing path, which is good. So I'm expecting to get another version of the draft out shortly. And then if any comments come in after that, it can be revised further.
Thank you very much, Brian. It's Rick here. I did receive a prompting email from the document management system to say the current draft expires on Monday.
Yes.
So it'd be quite nice that if it didn't expire between now and Monday.
Yes, I got
no pressure. But
I do have a pending revision that I missed a chance to commit just before the meeting.
No trouble.
That's all I have.
Brian, Mark here. I don't know if you heard, but we are expecting a review soon for your document.
Yes. I did want to get, just because there was that one structural change to the contact header, I did want to get that out just so that it's available.
Sure, I don't think anyone has any objection to a number of quick revs. You know, if you want to make the change and put it out, it costs nothing really.
Okay.
Thank you, Brian. So if there's any no other comments, we'd like to summarize our, next steps. We will be sending the BP-BIS to ISG. We're waiting for the write-up of the document Shepherd. As soon as it's there, then we'll send it to the ISG. TCPCL will, as we just described, will be waiting for review and final draft, and we will send this to the ISG unless there's a big change, on the spec, which we aren't seeing at the moment. We will ask working group to adopt the custody transfer draft to be a working group item. We'll ask the working group for working group adoption for the Cipher interrupt draft. We'll ask a security directorate review for the BPSec. We'll do a working group last call on BPSec, and we'll ask a working group adoption for the draft DTN AMA. That's kind of a large pile of things. So expect a lot of emails in the next weeks for all those adoptions, requests, and things like that. If no other comment, then we'll close the meeting. 1:12. Okay, thank you very much.
Thank you. And thank you very much for all the speakers and presenters. Always helpful. So we've got an enormous list of stuff to do. Great.
I started to lose nuance when I'm talking to you guys like this morning. I really do want you to do the chair's work.
No, it's actually really helpful.
I mean, there are things I know, but I want you to do the right thing based on what I know that I told you, not
Words of no notes.
I suddenly, I sit down, I started thinking, does it sound like any of that was condition? I haven't seen it.
No, I think